So I already have the data set in my Google Drive as a Google Sheet document. And with this cell here, I'm trying to read it into Google Colab so that I can do the assignment and the visualizations. So here I'm authenticating, I'm allowing Google Colab to access my Google Drive and read the Google Sheet, which is titled Literacy Rates Updated, Sheet 1. And then it is printing all the rows. And then this line of code finally converts it into a data frame. And I'm telling it that call my data frame DF. So let me just run this. So it's done with running. I can do .head to see the first 5 rows. So from here, I can see that my column names are 0, 1, 2, 3, 4, and 5. And I don't want that. I want this index, the row at position 0 to be my header. So that is how df.columns equals to df.ilog0 comes in, because I want the row at position 0 to be the headers. So I'm just going to run this. And then if I run df.head again, we can now see that region, country, year, which was initially at position 0, is now my headers. Now I don't need this row here, this row 0, this row at position 0. I don't need this anymore. So let me just hide this out first. That is why I'm going to say df.ilog1. I'm basically saying that I want my data frame to contain only rows from position 1 and beyond. And I'm resetting the index. If I don't reset the index, it is going to start counting from 1 itself, but I don't want that. I want it to start counting my rows from 0 itself. That's why I'm resetting the index. So when I do df.head again, I can now see that region, country, year, age, gender, literacy rate are now my column headers, and my indexes are right, starting from 0, 1, 2. It has been reset right. So I started by checking the duplicates by using df.duplicated keep equals to false, because I wanted to see all the 2 values. So yeah, that was the result. And then to delete them, I used df.drop duplicates in place equals to true. This drops duplicates in that data frame. The changes reflect on my data frame with the in place equals to true. So when I run df.duplicated equals to false, I can see that there are no duplicates anymore. So df.columns, just to see my columns, and then usually I like to check the unique values of each column to further understand in case there are any discrepancies in the categories, something like that. And we'll see that as I go on. So df.age.unique, I want to see the unique values in age, and there is actually nothing wrong with this. That's what I expected. But when I run gender, I can see that there is female, there is male, there is F, and then there is M. I'm assuming F represents female and the M represents male. So I'll go ahead and use the replace method and dictionaries to replace F with female and capital M with male, just to ensure consistency in the categorical values. So this one here is the value that is supposed to be replaced, and this one here is the value that is the new value. This is the old value and then the new value. I'll just run this, and then when I run gender.unique again, I can see that now I have male and female only. Then also year.unique, I want to say the unique values in year, just to give me a glimpse also. So from here, I can see that 2011 has an underscore, which is not supposed to be the case. So to do away with this underscore, I'm going to say df.year equals to df.year string r strip, underscore. The underscore. Why am I saying R strip? It is because this underscore is on the left of 2011. So when I run this, and then I run this again, I'm going to see that now 2011 is sorted. The underscore is not there anymore. But also still from this df year.unique, I can see that I have what? 3014, and we're in 2025, so this must be an error that needs to be dealt with. So here I went ahead and filtered where year equals to 3014. If I run this, the result must be down here. And actually, yeah, there is only one way that has been affected by this error. So I went ahead to do df.sum to check any missing values, and there were none. So going back to this issue of 3040, this here was intended to show for me the rows from to slice the rows from for me the rows from 3308 to 3310, and then at df.tail I want to see the last 10 bottom rows. So the error of 3014 is right here, and I can see that it's actually between 2014. That is why I assumed that this must be an error in entry. So I went ahead to replace 3014 with 2014. I did this by saying df.year equals to 3014. This one here gives me the row, but by specifying year here, I get only that specific column. If I did not put year here, the entire row would be replaced by 2014, which I don't want that. So I had to specify the year here to make sure that only the column year is replaced with the 2014. So when I do the F year.unique again, I can now see that the 3014 is not there. And now these categories here make sense. df.columns, just to check my column names again. Then df country.unique. These were many, and I really didn't get anything to change in there. Then region.unique. From here, I can see that there are empty spaces in the column region. So I went ahead to filter where region is empty, and this was the result. So I can see that this country and this country had missing values. So I firstly filtered where country equals to Afghanistan to find out the region. And because not every country had the missing value, right? So I could see the region from the other rows that had the country Afghanistan, and I found out that the region is Central and Southern Asia. So that is how I went ahead to filter where region is empty and country equals to Afghanistan, and the region, give me only the region, then replace it with Central and Southern Asia. So when I run this, and if I run this again, I will see that the empty spaces are only with Uzbekistan. Yeah, something like that. So for Uzbekistan also, I found out from the very data that the region is Central and Southern Asia. So I went ahead to filter where region is empty and country equals to Uzbekistan, then give me only the column region. In there, replace that empty space, replace it with Central and Southern Asia. Yeah. So that was that. And then gf country.head. This was the code that was helping me to see the region. So for Afghanistan, I put Afghanistan here, and I could see the region where it lies. Uzbekistan, I could also see the region where it lies. Yeah. So when I run region.unique again, I can now see that all the values are there and there is no missing value actually. So df.columns to see my columns again. So now here df.dtypes to check my data types. And according to the question, year had to be in integer and literacy rate had to be a float. So df.year equals to df.year as type integer because I'm converting it into an integer. And then df literacy rate dot unique. I wanted to check the unique values in literacy rate, but there are actually so many, and I figured out that this is actually not going to help me. So df literacy rate equals to as type float. So here I encountered this error of 45.38. So I said I filtered out using string contains this percentage sign because I thought that there were very many rows with this percentage sign. So this one actually helped me figure out the column. So df.string contains percentage and it is in the column literacy rate. So I went ahead to equals to this very where the string contains the percentage rate and it is in the column literacy rate dot string arrow strip this percentage sign, like remove this percentage sign which is on the left of this number, then convert this number into a float because I can't divide a string. So I first converted this number alone into a float and I divided by 100 in order to make the number similar to the rest. So I run this and then df.ilog12 is because this 45.38% was in this index 12. So when I run this again, I can see that the error was actually fixed here. So it is now similar to the rest of the other values. And then also when I tried to run, when I tried to convert literacy rate to float again, I noticed that there were some missing values in literacy rate. That is why I decided to filter it out from here. Df where literacy rate equals to an empty space and region equals to Eastern and Southeastern Asia. That is why I have this line of code here. So I'm importing numpy as np because I want to replace none where there are spaces. Okay, where there is no value, I want to replace it with a none. Because none can easily be converted to float, unlike an empty space. So here, even the none is being converted into float. So when I check the data types, you find that literacy rate is in the data type float. However, we have some missing values, which I'm filling them using the mean. That is why I got the mean of each region using the group by function, region literacy rate, and then the mean, which I'm going to use to fill in the missing values. So for Singapore, there was an input from the country Singapore, which had a missing value in the literacy rate column. So I went ahead to get to filter out where country equals to Singapore in the column literacy rate to get the mean so that I can use this mean to filter where there is an empty space. That is now where this line of code comes in. Literacy rate is now, and the country is Singapore, and the column literacy rate, the value should be mean Singapore. So I run this. Then df.ilog 498, ilog 498, the index 498 was the one representing the row where the country was Singapore and literacy rate had a missing value. So here we can see that it has been filled with the mean. So that's done. Then literacy rate that is now. So from here you can see that these ones here that have none here have come from the same region. That's why I use the mean from the region Europe and Northern America to populate these values here. That's where this block of code comes from. Where the region is equals to Europe and Northern America, and literacy rate is now literacy rate, per column literacy rate. Fill in mean ENA, that is Europe and Northern America. So my values have been filled. There are no none values in the data set right now. Everything has been populated with the mean. So df.data types, and I can see that my year is in integer form and literacy rate is in float, just as the question required. df.columns to see my columns once again. Right now, I'm starting my visualizations, which is why I'm importing matplotlib.pyplot and seaborn. So df.columns to check my columns again, and then a bar graph showing the number of participants by region. By region, Latin America, Sub-Saharan America had the highest number of participants, and Oceania had the least. So from here, I'm giving it a variable name region size, df group by region and then size. Why size? Because I want to, it's almost like counts. Something like value count, I can say something like that. So plt.bar, I want a bar graph where region size is the index. Region size.index is the x, it's gonna be in the x-axis, and then region size.values is gonna be in the y-axis. So I wanted data labels on this chart, which is why I have this code for I and V in region size values. So I'm basically telling it to loop through region size, the values and the index, and then it picks for me the index and the value, and it converts the value into a string, and it positions it at the center, at the top of the bar. Somewhere here, that VA bottom. This VA bottom means at the bottom top of the bar. I hope that makes sense. Then PLT, X label region, Y label is number of participants, number of participants in each region, and then plt.show to see a graph. plt.xdix, rotation equals to 90. I wanted to make this more readable. Like this, it's more readable. Yeah. So this graph, you can see that Latin America and the Caribbean plus Sub-Saharan Africa had the highest number of participants in this survey, and the rest, Oceania had the least number of participants. That was only 96. And then this was a graph that shows number of participants by age group. Still again, age size using the F group by finding the value counts for each age group category. So still again, it's a bar graph. plt.text, this one is to input data labels at the top, at the bottom of the graph, at the top bottom of the graph, something like that. So when I run this, still again from here, we can see that the age is equally distributed. It's almost equally distributed. The graph shows the number of participants by age group. The graph shows a fairly even distribution of participants across the various age groups, although the below 15 category has the highest number of 840 and 60 plus being the lowest with 811. Even with that, you can see that there's a very minimal difference. So the different age groups were catered for in this survey. So moving on to the multivariate analysis. This is a bar graph showing the relationship between the number of participants and literacy rate per region. So this here, subplots because I want to show two graphs in one figure, which is both the which two graphs which are sharing the same x-axis but different y-axis. So AX1, which is my first graph, is going to be a bar of region size index. Region size index is the other x values, and region size values are the y values. AX1 label is region, AXY label is number of participants, AX1 title, basically the title of the entire graph is relationship between the number of participants and literacy rate. And then X-tip labels to make the X values readable. Then AX2 equals to AX1 twin X, AX2 twin X because I want AX2 to be on top of this bar graph and to share the same axis with it. Then this one is the mean of literacy rate per region. So from this graph, we can actually see that Sub-Saharan Africa had the highest number of participants, but it had also the lowest literacy rate. So Sub-Saharan Africa needs more literacy enhancing programs. For Oceania, we know very well that the literacy rate was got by dividing the number of people who can read and write by the total number of people in that region. So for Oceania, the population is very few, which makes the literacy rate to be very high because if you divide any number by a small number, usually the result is big. So we cannot conclude that Oceania has a high literacy rate because of the small population, because of the small total population that was used to divide with the number of people who knew how to read and write. So Oceania is one of those regions that needs more literacy enhancing program. Same for America and Asia. Same for Eastern and Southeastern Asia. They also had very few people. They had moderately few people, but high literacy rate. And with this, we cannot conclude that they have a high literacy rate since the population is very low. But for Latin America and the Caribbean, this one I can confidently say that they have high literacy rate because even the number of participants were many. Yeah, because even the number of participants were many. And so Latin America and the Caribbean, for now, they do not need literacy enhancing programs. So that is it about this graph. It is basically showing the relationship between the number of participants and literacy rate, how the number of participants affected literacy rate and all that. So it is not safe to conclude that just because the literacy rate is high, that means that the people actually know how to read and write. So df.columns again to see the columns once again. That is a grouped bar chart showing how various age groups are distributed across the regions. So DF age region, group by age and region. I'm grouping by two categorical values here, and I want the size and stack. Then DF age region, I want a bar graph of the size 8, 5. So from this graph, you can actually tell that for each region, the age groups are quite the same. A group bar chart showing how various age groups are distributed across the regions. Each age group in the region has been consistent. That is it. Thank you so much.